I want to go back and I want to talk a little bit about this before we begin. When we started our conversation, I said to you guys that there are two basic kinds of cycles that we know of. They are different names that everybody gives them. I've been thinking about this for a long time, and this is what I've decided to call them. I'm going to call them work to heat transfer cycle, or heat transfer to work cycle, or heat transfer to power cycle. It is a very clear way of describing these two cycles, right? And don't get confused. All it is in one case, heat is being used to generate the work. In the other case, the work is being done to take heat where it doesn't want to go. So the next week and today, we will be talking about both of these cycles. So we'll start with the refrigeration cycle today, and then we will continue next week and talk about the other cycle. Okay, so now going back to what we're going to do today. So going back to the Carnot cycle. The Carnot cycle is what we discussed the other day, and we called it the absolute perfect ideal cycle at 40%, give or take. Awesome. So now I'm going to talk about the refrigeration, but do you guys remember this picture here? What does this picture show you? Anyone? What is it doing? Yeah, this was the class before last class. So it's taking a temperature gradient, heat moving from hot to cold, put an engine in the middle, get work out. Okay. So get work out. What if I wanted heat to go where it doesn't want to go? What do I have to do? Yeah. Put work in. So I have to put work in to make this temperature go that way. Agree? That is the basic principle of our work to heat transfer cycle. So these are called work to heat transfer cycle. So the device that does it is called heat pump. And you will see these cycles also called temperature cycles in other textbooks, just so you know. These are also called temperature cycles. Everybody want to draw this picture? What it's doing is it's taking work in to move QC to a higher temperature. Actually, no, I should call this TC to TH. In a nutshell. What are the two things you can think of right off the bat that could be your temperature cycle? Very quickly. You're sitting in a warm room, heating and air conditioning. That's it, pretty much. You can either move your, if outside is cold, what do you want inside? If outside is warm, what do you want inside? That's it. So the two different kinds of things are called heaters and refrigerators. How do I write this? heaters and refrigerators. Good morning. And going back to the other cycles, we are still going to use the same terminology, source and sink. What is source? Which has high temperature. What is sink? Whichever has the lower temperature, right? So we're still going to use our same terminology, source and sink. Source is spelled with a C, right? Okay. So what is the principle that is being used in this case? The main principle. Anyone want to take a guess? What is actually happening? True, no, but the principle behind it. No, that's you telling me what it. I want to know the big picture. There's only one thing you want from both of them. That's it. Make temperature go where it doesn't want to go naturally. So make heat go where it doesn't want to go. So what was our first law of thermodynamics? No, actually, what was our 0th law of thermodynamics? What was our 0th law?
If systems A and B are each in thermal equilibrium, with a third system C, then A and B are in thermal equilibrium with each other.
Good. What does that mean in proper language? If you put two things together, one at higher temperature, one at lower temperature, what will happen?
Come to equilibrium.
Which means one will gain, one will lose. What if you want to move it the other way around? That will be an unnatural process. What do you have to do to cause that unnatural process to work? Does that make sense? That is the principle behind all of that, all of this stuff. So the basic principle is make temperature where it naturally will not go. You want to heat this room. Heat wants to, is it cold outside today or hot?
Cold.
So if you heat this room, where does heat want to go?
Outside.
If it was really hot outside, where would heat want to go if this room is cold? Move in, correct? So now what does an air conditioner do in the summer? It takes heat from your sink and puts it to the source. What does a heater do? Now the sink is outside. Takes heat from the actual hotter air and put it to the outside, which is actually even hotter. Right? So in order to do that, we have to do work. Okay, so what do they look like? Ta-da! That's your refrigerator. That's heat you want to remove into the environment, which is already hot. So you have to do work. A heater, cold outside, a warm house. You want to take heat from outside and put it back in. So again, you have to do more work. You see it? Where would the heat naturally go from your house if it's cold outside? What do you have to do in order to get heat to go from the colder into the warmer? Yes, sir.
Dr. Sim,
Yes.
You wrote up a little bit. You said make temperature go where will not, where it naturally won't go.
Oh, so I should probably call it heat.
Yeah, I was gonna ask.
Yep, heat, temperature.
Okay.
I thought about it. Yes, it should be heat go where it does naturally will not go.
Thank you, Dr. Sim.
Mhm.